I'll send you a link. Okay. Anyways, we are doing our review for our Chapter 14 test. So what I'll do is give you an example of each topic, and then you'll be on your own to review that. First thing, solving trig equations. Now there are going to be a variety of forms that this is going to come into for your test. So they could be simple, they could be more difficult, but something like this. Say we had 4 sine theta plus 2 root 3 equals 0. So fair game. Factoring in quadratic equations coming into these is fair game. In each trig equation, our goal is to isolate whatever the trig is and then solve. Okay, so if I have squares in the mix, that's going to tell you that you're going to probably have to do some factoring. If I have more than one trig thing, that tells you also that there's going to be factoring. Alright, so I don't have more than one trig thing, so there's not factoring. What do you think we should do first? Yes, so I get negative 2 root 3 on the right, and then I have 4 sine of theta on the left. Now what do I do? Divide by 4. So I get sine of theta equals negative root 3 over 2 after I simplify. If I do inverse, what do I get? Negative 60, he says. Okay, so negative 60 degrees. So we're going to adjust that to 0 to 360. So we're going to add 360 to adjust that into 300 degrees. Is that the only place sine is negative?
Yeah.
No. It's also negative in which other quadrant?
4. I mean 3.
Yeah, we have 4 and 3. We have our fourth quadrant. So when we try to get this third quadrant answer, our reference angle is 60. So from here to here is 180. I have to go an additional 60 to get that. And I get 240 as the other answer. You can graph this. If I graph it, I do y1 as 4 sine theta plus 2 root 3, and I do y2 as this stuff on the right, 0. And then I graph solve, or if you're on a TI, calc, and I graph solve for where these intersect. And you will get multiple answers. Now in the case of the 0 being here, it's going to be hard to see. Especially on a black and white calculator, it's going to be hard to see where those answers are. But you have to, you would have like this, and then you'd have some sort of thing, and then you're looking for these points, and you'll have to get each one. You should get these 2 answers if you do that. So graphing is always a good way for you to check your work. Another one, let's say I had 2, I'm making this up off of the top of my head, so I might have to change it a few times. So let's say I have cosine squared x plus, let's say I have a 2 cosine x plus a 1 equals 0. Okay, I am going to have to factor this, but I can't factor out a cosine because this does not have a cosine. It factors like this: cosine x plus 1 and cosine x what? No, plus 1. It's the same thing again. Okay, not a minus 1. Don't assume that if this sign is positive, that tells me these 2 signs here are the same. So these are the same thing. So I say cosine x plus 1 equals what?
0.
And then I subtract that 1. And then I inverse cosine. So cosine x, or x equals, what's the inverse cosine of negative 1? 180. And that's actually the only answer. Okay? I'll give you a second to get that. Let's do another that involves factoring. Let's say I have cosine squared x plus cosine x sine x. Maybe we'll put a 2 right there. Put a 2 right there. I like that. Equals 0.
That's plus 2 goes.
Yep. Okay? So now it factors different. What could I factor out? Yeah. And then what do I have in the center here? Cosine x plus 2 sine x. Okay? So this part is going to be a little bit tricky to simplify, but we can get there. This one, cosine x equals what?
0.
And inverse cosine, I'm going to get 90 degrees and 270 degrees are the 2 places. This part, that's going to be cosine x plus 2 sine x equals 0. Now, I'm probably not going to give you something that turns out like this. But if I did, what we would probably do is actually something that's not intuitive. We'd subtract this to the other side. And then y1 equals cosine x. y2 equals negative 2 sine x. And then we would do our g-solve on our calculator. So I probably won't give you something like that. Probably more likely, I would give you something more like this. Cosine x plus 2 sine x cosine x equals 0. I probably won't give you that squared. So again, what would we factor out? Cosine. And then what do we have right here? 1 plus
2 sine.
Yeah. Alright, so now cosine x equals 0, or 1 plus 2 sine x equals 0. Alright, so we inverse cosine, and again we get 90 and 270. Right here we'll do what? Subtract the 1. And we get negative 1, then what do we do?
Divide by 2.
Divide by 2. So sine x equals negative a half. And then what do we do?
Inverse.
Inverse. Now, before we go to the inverse, we should take a moment to think. We should have a quadrant 3 and a quadrant 4 answer. So when we inverse sine that, what do we get? X equals?
Negative 30.
Okay, so that's going to be 330 degrees. So that's the quadrant 4 answer. What am I going to use for my reference angle? 30. So from here to here is 180. And then plus an additional 30 gives me 210. And again, if I wanted to check my answer, y1 would be cosine x plus 2 sine x cosine x. And y2 would be what? 0. And then I g-solve that. And I need to get 2 answers.
So 90 and 270 is also 2 answers?
Yep. These 2. So I have a total of 4 answers. So I should get 4 answers there. Okay. Next thing that you need to be able to do are identities. Are you okay solving? Like you understand the concept? We're good? Okay. Alright, identities. You need to recognize your Pythagorean identities. That's going to be sine squared x plus cosine squared x equals 1. And 1 plus cotan squared x equals, what goes here? Cosecant squared x. We divide this one by sines, and we get this. If I go back to the beginning and I divide by cosines, I get tan squared x plus what?
Wait, what?
1 equals secant squared x. So your guys are kind of lost. I'll take a moment to re-explain. Memorize this one, and then from it, divide everything by cosine squared, and you will get this one. 1 divided by cosine squared, secant squared. What's cosine divided by sine squared? Cotan. What's sine divided by sine? 1. And then if I also start with that same one and divide everything by sine squared, so I take all of that and divide it by sine squared, I will get this Pythagorean identity. Because what's sine squared divided by, I did that backwards, didn't I? This one is, oops, this one should have pointed down to here. What is sine squared divided by cosine squared? And what's cosine divided by cosine? And what's 1 divided by cosine? Secant. And then if I divide everything by sine, what's sine divided by sine? What's cosine divided by sine? Cotan. What's 1 divided by sine? Okay, so I flipped those around. My apologies. Those are backwards. But you get the idea, I hope. Okay, so if you memorize that first one, you can get the other 3. You need to recognize the various forms. So if I start with this one, you need to recognize then that sine squared also equals 1 minus cosine squared. You need to recognize that as equivalent. Does that make sense? And I also need to recognize from that one that cosine squared also equals 1 minus sine squared. Well, how do I get those? If I subtract cosine squared, 1 minus cosine squared. If I subtract sine squared from both sides, I get this. This is what we did before break. Okay? So it's been a while since you've seen it. Okay. Let's try to construct those. What's the first Pythagorean identity? Say it to me.
Sine squared plus cosine squared.
Good. How do I get the next Pythagorean identity? Try to do it. Divide by sine. What do I get?
1.
Plus. Okay. How do I get the next one?
Divide the top one by cosine.
Yes. Divide the top one by cosine. What do I get?
Tan squared.
Tan squared plus
1.
equals?
Secant squared.
Good. All right. And then the various forms. So what else do we need to recognize? That 1 equals, if I take this one and subtract both sides by tangent, that 1 equals secant squared minus tangent squared. You need to recognize those various forms by adding and subtracting the different ones. But these are your base 3 of your Pythagorean identities. Then you have secant x equals 1 over cosine x. These are not Pythagorean, these are reciprocals. Cosecant x equals 1 over sine x. And cotangent equals what? 1 over tan x, right? Those are your reciprocal identities. Then you have your tangent identities. Tangent equals sine over cosine. And cotangent equals cosine over sine. Okay? So, Pythagorean identities, these are your reciprocal identities. And these are your tangent identities. Okay? Don't erase it, he says. So I'll leave it up there as I write what you'll need to be able to do. You'll see. Okay? I'm going to go on because they're actually still on the board. So you can get those at any point. Alright, so I'll paste this. Move it up here. What you'll need to do is verify the identity. Now here's the thing. You're not going to have a lot of these on your test because they are time consuming. That means you have to nail the ones that are there. So they're all very different. So the guarantee is you're not going to have this one, right? But it's the process. When we verify an identity, we choose one side to work on and not the other. We want to get the left-hand side to look like the right-hand side. So we only work on the left. And a trick is usually to switch to what? Sine and cosine. So I could switch secant to 1 over cosine. Leave sine. But I might want to put it over 1 so I don't mess up my numerators and denominators. And what can I switch cotangent to? Careful. Cosine over sine. Okay? And then, and you need to show this step, we see that sines cancel, and cosine cancel, and that gives me 1 equals 1. Verified. Okay? I'll come back to it in a minute. I just want to grab these so they're in front of our face. Okay. So which of these Pythagorean identities would I use to help me with this one? Yeah, this second one. Okay. So I see and there's a lot of ways that I could do this, right? But I can only work on one side. So I need to get this equal to 1, this left-hand side. I could replace the cotangent, or I could replace the secant. I'm going to replace the secant because of my Pythagorean identity. It's already solved for cosecant. Do you see that?
Yeah.
So I'm going to replace cosecant with 1 plus cotangent. Do we see how I did that? I replaced this with all of that. Then I have 1 plus cotan squared x minus cotan squared x. Do you see what happens? These undo each other.
I have a question.
1 equals 1. Yes?
Why couldn't you just add cotangent to the other side?
Because when you're verifying, what you're saying is not wrong. Okay? Except for if we're verifying the identity, we can only work on one side. So I have to build a wall here and never cross it.
Oh, okay.
Okay?
Yeah, I got you.
But as far as if you were solving something, what you said is not incorrect. If and you could if I started with that, and if I were solving this for some reason, yes, I could add that, and then I get this, which is a form of this, right? Yes. All right. I don't want to spend all my time on this, but here's another one. What's a trick that you might use here? What's a trick that you might use here to verify this identity? Which side do you want to work on? The left. Okay. Okay.
And then secant over 1 over cosine.
Cosine cancel and 1 over sine equals cosine.
Yep.
Is that the ones that's going to be on a test like that? Please say yes.
They are varying difficulty. Well, you're not going to have many of them. So you might have 2, maximum of 4, probably 2 of them. So probably 1 easy and 1 hard one. Okay, so page 960, numbers 6 to 13 are excellent practice of this. Okay, of what we did before. Actually, that's the very beginning. Those are going to be good references for you. Actually, looking at your test right now, I see 4 of them. There are 2 easy and 2 hard.
Oh, I think they'll all be easy.
Okay, next type.
Oh, yeah, are you going to give us page numbers practice on solving tricky equations?
Same page, actually. Yeah. That would be 14 to 25. So if you want solving practice, same page as here, but going on 14 to 25.
And that's solving tricky equations?
Yep. Specifically 22 to 25. Okay. Going on. We are now on solving right triangles. So this is where you can use sine, cosine, and tangent, right? Sine of an angle is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Also, you're going to need to use cosecant is this one flipped. Secant is this one flipped. And cotangent is this one flipped. Remember that the angle is an essential part of this. Alright, so let's say that this is 6 and this is 2 and this is my angle. So right here's my angle. What would be the sine, the cosine, and the tangent? Yep, excellent. So we need to use Pythag. Use Pythag to find this missing part. Alright, so go ahead, Jarrett, set up our Pythagorean.
2 squared plus b squared equals 6 squared.
I'm going to go ahead and use an x,
Okay.
but that's okay. You can use whatever variable you would like right here. And we're saying that x is this length right here. So 4 plus x squared equals 36. Now what?
Subtract 4.
So x squared equals 32. Now what?
Square root 32.
And we'll need to simplify that. So 4 root 2. So this is 4 root 2. Alright, so what's sine?
4 root 2 over 6.
And what should we do with that? Can we reduce this?
Yes.
Yes. So it's,
2 root 2 over 3.
yep, 2 root 2 over 3. Good job. How about cosine? What's that?
2 over 6, which is 1/3.
So that's our answer. Here's our other answer. And tangent.
4 root 2 over 2.
Which I reduced to
2 root 2.
2 root 2. Okay, I'm going to erase all this stuff that's over here, just to give us some room. Alright, what if I wanted cosecant, secant, and cotangent?
Just pretty much flip it around.
Yeah, and I would this one's going to be easy, 3, right? I would go to, this is going to be a little bit tricky. What's our denominator here?
1.
A 1. So this is going to become 1 over 2 root 2. Can I leave it like that?
No.
I need to rationalize, right? So I get root 2 over,
2.
well, it's going to be 2 root 4. So if we do that out, we have root 2 over 2 root 4, which is root 2 over 2 square root of 4 is 2. So that's a 4. And then right here, we'll flip this one, and that's going to be 3 over 2 root 2. And again, we need to rationalize, and we'll get 3 root 2 over 4 for the same reason. Okay, so those are our final answers for that. Any questions on doing that type of problem? Okay.
I'm confused. No, I'm just kidding.
Well, I was going to go.
No, I'm kidding.
I was going to go back over. Okay, we ready?
No.
Okay. Since you were being sarcastic, I figured
Yeah.
just whatever.
I just wanted to see what the publication.
You know me, Wilson.
Yes, if means upperclassmen.
It's my cold.
What's the quiz I'm taking today going to be go over?
Some difference of all signs and all cosines.
Yeah, hopefully we'll get to that Okay, so basically, I mean, I might phrase the directions differently, like find all the missing pieces, in which case you might put in here, all right, here's my x, here's my y, here's a z degrees, you know, find the missing parts.
We have BC.
No one asked you. AC, that's what I meant. Okay, how could I find z? Z in this case is going to be easy to find. How do I find it?
180 minus 90 minus 40.
Yep, because this is a right angle that's 90 degrees. So what do we get?
50.
All right, done. How do I find segment AB? This segment, using only the information I'm given. So I have this, and this.
You use sine.
Yeah, opposite over hypotenuse. So sine of 40 equals.
3 over 1.
Now what do we do?
Multiply by 1.
And then
Well, that's not 40.
okay, so what's 3 divided by sine 40?
4.7.
Now, if I'm going to avoid using that, how do I find x? I have opposite and
Tangent.
adjacent, so tangent of 40 equals
3 over x.
multiply both sides by x, divide by tangent,
3.6.
there are a lot of different versions of this. Let's do 2 more, and then I'm going to hop over to law of sines, law of cosines. And sum and difference, because sum and difference is on your quiz. Okay, so I am going to move even faster. Are you okay? Are we good enough on the right triangle part that I can move faster so we get to law of sines, law of cosines?
Don't move too fast.
You can say no if you want. Okay.
You don't get yesterday.
Let's just use a basic right triangle. We'll already have everything solved. Let's say I want these 2 angles. Yeah, that's fine. So we have a lot of different options here.
You can do sine A over 3. You can do anything.
Yeah, because I know all the sides, I can do anything. So, but if we're missing a side, then that will limit us. So to find A, let's say I said sine of A. How would I set that up?
3 over 4. I mean 3 over 5. Sorry.
3 over 5. Okay, what's another way I could find A?
3. Yeah,
Cosine A, in which case what would that be?
3 over 4.
4 over 5?
Yeah.
And one more way.
Which is 3 over 4.
Alright, now what do I do from this step? Okay? So more likely you'll have one of these missing. Like I'll say, nope, you don't have that one. Okay? And then you'll have to decide which one of these to use. Alright, so we inverse sine, and what do we get?
36.9.
Okay, so no matter which one of these used in this case, you'll get the same thing.
Really?
You with me?
Yep.
Okay. Alright. Let's
Go.
That was like perfect.
okay. Set that up. This is a right triangle. Let's just set it up to find each one.
Pythag.
Okay, so we Pythag. So 4 squared plus 9 squared equals,
Z squared or Z squared.
so 16 plus 81 equals z squared. So 97. I can't add. 97.
It's 9.8.
It's okay.
So it's about 9.8. Okay? How do I find x?
It is 9.8.
Well, that equals right before.
Okay, how do I find x, guys?
Sine x
Yeah.
equals 4 over 9.8.
I want to avoid using that.
So you use tangent.
So tan x
Opposite over
equals,
adjacent.
so 4 over 9.
Yeah. Sorry, King.
So what do we do next?
Inverse.
Inverse.
You get 23 point, no, 24.
Duh, girl.
Okay, and if we were setting up y,
You would use tangent again.
okay,
4 over 9 again.
no,
9.
I mean 9 over 4, sorry.
9 over 4. And then we inverse tan that.
Couldn't you just do the 180 minus 90 minus 24?
Yes, we could.
66 point nothing.
So 56.
I said
Okay.
66.
Oh, 66, sorry. 66.
You're going to have a heart attack by going too fast.
What?
Harold.
Okay,
Might go a long time, sir.
almost. Okay, how set up to find x?
Opposite over hypotenuse.
Sine is x.
Sine
20.
20,
X over 10. Multiply by 10.
so 10 sine 20 equals x. Alright, set up to find y.
You use cosine.
So cosine
20.
equals
Y over 10.
y over 10.
You do the same thing. Multiply by 10.
I got you.
Is that familiar?
Yes.
You good?
Yeah.
And then you put that in your calculator.
See, senor.
Okay, law of sines, law of cosines.
What you looking at that for, King? I almost fell out my chair.
Alright, law of sines
Yay.
is the sine of any angle over its opposite side equals the sine of any other angle over its opposite side. You could, it doesn't matter the letters, it's the same concept. So if this is 40 degrees here, and I'm making this up, so don't be surprised if it comes out weird. And let's say this is,
Is that 9?
X.
Is that
let's
a
say
9?
that's 20 degrees, and yes, that's a
I didn't
9,
know if it was
over x.
You do times 40 over 9.
Sine 20 over x.
Then you cross multiply.
X sine 40 equals 9 sine 20.
You divide by sine 40.
Yep.
Yep.
And then Josh can finish it because I don't fight.
Okay, make.
4.8.
Okay, so he says 4.8. I'm just going to trust that that's correct.
It's probably you don't.
Any questions on how we set that up?
Don't erase
Hold on,
it.
wait.
Erase it. Don't be racist.
Yeah, well, on the internet.
Hi. Hit me up at Cambo 3218.
Wait, hold on, wait.
He's an Xbox loser.
We don't have a lot more time, so I need to move on.
I'm ready. I'm ready.
Since it's recorded, we're going to move on.
Yeah.
Why you guys make weird triangles?
Because he gets to.
Oh no. He gets paid to
Jared.
What?
Stop.
It's true, actually.
Okay, set this one up.
Sine 65 over 12 equals sine x over 10. And then 10 sine 65.
So we cross multiply. Yep.
12 sine x. And then divide by 12. And then when you get whatever, when you divide by 12, you do inverse.
So we inverse sine that. So we'll see how good I came up with this question. Okay, so we got point. So we're going to inverse sine of 0.7552.
It's 3.
Okay, 3, whatever.
It's 49. Exactly. Or 49.1.
Wow.
What
Make
is?
examples of this, even though we did a lot.
Okay, if you want examples on this, you're going to be doing page 961, numbers, and actually of what we also reviewed already, 28 to 42. Gives you extra examples.
Is this like a review pages?
Yeah, these are the review pages in your
We're
textbook.
do all
Then.
cosine now.
Yep. Law of cosines.
Grant, can I have a piece of
Wait,
paper?
what are the numbers?
Huh?
28 to
42.
It's on the board.
Yeah.
Okay. Law of cosines. Basically,
It's a formula.
it's a squared equals b squared plus c squared minus 2bc cosine of a. See, the key here is this side and this angle are opposite each other.
That's
Okay? And then these two things, b and c, are the two sides that meet this angle. So in any triangle, I'm just going to use DEF just because it's different and to emphasize that it's the pattern of the sides. If this is the angle I'm looking for, then I would probably have a situation like this.
Squared equals.
So we know it's not law of sines because I don't have any of the other angles. For law of sines to even be a possibility, I need one of the angles, and it's not even then. It's not always. So I like doing this, and then these are the two things opposite each other. So 10 squared equals, and these are the two things then that are going into here. So it's 12 squared plus 6 squared minus 2 times
6.
yes. And we need to remember not to combine these all together because this makes it not a like term. So I have 100 equals 144 plus 36 minus 2 times 12 times 6. Watch your signs. That's a negative 2, making this negative 144 cosine x. Now what?
Subtract 180.
Because when we combine these, you get 180.
Oh yeah, sorry.
So yep, we subtract the 180, we get negative 80 equals negative 144. Watch that you don't lose that negative. And then we divide by negative 144, and we get, yep. And then we inverse cosine that.
56.2.
Easy peasy. 56.2.
Okay, suppose then I said find y and find z. What would you do? Let's just set up finding one of those other ones. So we found this one. Alright, so how do we find z?
Okay, so 6 squared equals 10 squared plus 12
Wait,
squared
Z.
minus 2 times 10 times 12 cosine
10
10
times 12
12.
cosine z.
See, I'm going too fast for you, and I can't.
So that
That would be if I'm finding z.
okay.
Okay? So then in green, you do this. Now after I have two angles, what could I do? 180 minus both of them. Whatever they are.
Easy.
I get it wrong with this, bro.
Probably.
So
That's
this
how.
is what the quiz is over today. Now,
And some difference.
Yes, we are into the sum and difference, so we're at the end of class, so we're going to go even faster.
We don't have to do another example.
I'm going.
Oh, well, I get that. We get that. Can we not do that? I don't get that.
Okay, this is law of cosines again.
Yeah.
Are we paying attention?
X squared equals 7 squared plus 9 squared minus 2, 7 times 9 cosine 42.
42.
Yeah. X squared equals 49 plus 81 minus, hold on, there, 2 times 7 times.
So 18 times 7 inches.
Oh, poop dogs.
I sense that some of you are just messing around.
Negative 126. Oh, wait, never mind, I did that wrong. Don't listen to Josh.
Hold on.
Okay, so we're following the order of operations. X squared equals. We cannot add all of these together just yet. Well, actually, in this case, we can because we know this. You could just type this all into your calculator, all in one line.
This one?
But if we're doing it in steps, we would add these two together, 81 plus 49, and get 130. And then minus, if we have 126 cosine of 42.
So if you enter that all in your calculator, you get the right answer.
36.4.
So if you enter all that in your calculator, you get the right answer.
if you type in this line, as in this, all at once, you will get the right thing.
Okay.
And then we square root that.
Yeah, 6.
Okay? About 6, yeah. Just as a note, just like say this was 100 degrees right here. We still set it up the same way. But this is important. An important change that happens. The cosine of 100 actually is going to give us a negative number, which is going to make this become positive.
Yeah.
Because that happens sometimes. So when you're typing this little piece into your calculator, I would type in the -2, and just whether the calculator spits out a negative or positive, whether it's positive or negative, you put whatever the calculator has exactly. Okay?
Why are you two looking at me?
Because you're the one who does that. Alright, we're going on to area of a triangle. Now the area of a triangle is base times height divided by 2. But what we're concerned with is sometimes we don't have that. So sometimes we might have like 40 degrees here, and say I have like a 5 and a 12. That's when you need to make this right triangle and find this height. Now you can do that, but when you're doing it, you can't use the 12, can you? Can't use it. I have to use just this, and then you would get the height, and then you can use this formula. But there's a faster way. And the faster way is to do your two sides, whatever they happen to be, times the sine of the angle that's between them divided by 2. So in this case, the fast way to do it is to do 5 times 12 times sine of 40, all divided by 2. And that gives you the area of this triangle in its entirety without doing it in little steps. And the reason this works is because no matter what, you're always going to end up with the sine of your angle times one of the sides. Always, you'll end up with this. And the other side in here.
19.3.
Okay, so 19 point something. 3. Okay, is the answer to that one. Okay. Do you need another one, or are you good?
Good. We're good. Good.
Okay.
Can we go to something different here?
Shh.
Are you that?
I'll make him copy.
Are you that?
I think he's already copy.
Guys, stop. Okay, let's say I said find the area of this triangle. Notice now that it's not a right triangle, so I can't Pythag this side. Also notice that unlike this other triangle, is the angle between two sides that I know?
No.
No, it is not. So in this case, I need to do an extra step and find out what this angle is. Okay? And could I use law of cosines? Well, hold on. I have I can't find that, so I can't find this one directly. So I could use the law of sines to get this angle. And then I could do 180 minus 20 minus whatever this is. And that gives me this angle. And now I can use the trick. Do you see what I'm saying? So sometimes for the area of the triangle things, you have to do extra steps. All right. Sum and difference formulas.
Wait, when you start to find the other side?
After I get this angle, I have the two sides and the angle, and then I can use this.
Oh, so it doesn't matter which like corner you do the area with, you just have to...
It has to be a sides and an angle between them. Okay, however you get that. Sum and difference formulas. Alright, so we have sine, cosine. There is a tangent one, but it does not appear on your test or quiz, so I'm going to skip it. The sine difference, sine A, cosine B, minus cosine A, sine B. Cosine is cosine A, cosine B, plus, see it's a difference, but with the cosine it's switches, sine A, sine B. For your test, This will not save you. If you do not know how to do it, your note card that I'm allowing you to bring will not save you. But it will help you remember a formula. So on a 3x5 card, you may have any formulas or anything on it written down that you want to have. But if you do not practice and you don't know how to do it, it will not save you from a bad grade. You understand that? Open book tests just are the most dangerous things in the world because they give you overconfidence. Your book cannot save you from something that you do not know how to do. All right, so we have those, and we have sine of A plus B. It's going to be the same thing except plus, right? So sine A cosine B plus cosine A sine B. And here cosine A plus. This is going to be all of this except subtract. Now, that being said, what do you need to be able to do? And I am probably going to run out of time. So, like the bell is about to ring. So, do you want me to finish and take part of your break? Or do you want to just stop? Alright, well, I didn't get an answer to my question. But, let's say I wanted the sine of 15 degrees. Here's what you need to be able to do. And I say exactly. You don't just type 15 into your calculator. You say, alright, 15 I could express as the sine of 45 minus 30. Now I use my difference formula. That's sine of 45 cosine of 30 minus cosine of 45 sine of 30. Sine of 45 is one of those memorized things. It's root 2 over 2. Cosine is what? What's cosine 30?
It's the root 3 over 2.
Root 3 over 2 minus root 2 over 2, and sine is a half. Now I multiply those. Root 6. See, my denominators are the same. 4 minus root 2. That's the answer. I do not have time to do any more examples of that. Okay? As a someone, if you had, like, I don't know.
75 and you can do 45 without using.
I want to get to this next thing. You are not dismissed. Let's say I tell you that the sine of some angle is 2/5 and the cosine of a different angle is, say, 4/9. And I want the sine of A plus B and the cosine of A plus B, just as an example. What do you need to do first?
Find the other one. Find sine B and cosine A.
So I draw two right triangles. Grant, could you quickly lock that door? 2 over 5. Thank you. And 4 over 9. And now what do we do?
Use cosine rectangle.
How do I find this side? Pythag.
Sorry.
So this is root 21 by Pythag. How do I find this side? Pythag. I Pythag those. This is root 65. Now I can find, this is A, cosine is going to be adjacent over hypotenuse. And sine of B is going to be opposite over hypotenuse. Now I use my sum formula. What's my sum formula?
Sine A, cosine B, minus cosine A. Wait,
Plus.
sorry.
Cosine A, sine B. And now I put each of these in. What's the sine of A? 2/5. What's the cosine of B? 4/9. Plus, what's the cosine of A?
Cosine of A is root 5.
What's the sine of B?
So root 65 over 9.
And do you see what you would do here? You'd use the cosine formula. You'd simplify this. So this is 45. This is 8 minus, we would multiply those, root 21, whatever root 21 times 65 is, and be inside of a root. And then we do the same thing here, except we'll have a different formula. So we're on the very last thing. It's very easy. You ready? Let's say I have cosine of 65, cosine of 10, minus sine of 65, sine of 10. And I say, write this as one thing. This is a sum or difference formula. No, it's a sum.
Oh, yeah, I'm sorry.
It's cosine of 75. If I change this to a plus, now what is it? There's a difference in this cosine of 55. Make sense?
Yeah.
Do you want to know the difference?
Yes, I do.
Do you have a stapler anyway?
Yeah, it's at the front of the room.